All right, so what kind of solutions can we expect if we are trying to solve a linear equation? Let's take a look. So first of all, let's review what is a linear equation. So a linear equation is an equation with one or two variables, and the sum of the exponents of the variables is 1. So if we look down here, here are some examples. You can see here that the highest exponent on any of the variables is just 1. We don't have anything raised to a second power. All of these will look like lines if you graphed them. They might be like this. All right, all of these are linear. Right. And here are some equations graphed. So you can see that some of these are slanted, some of them are vertical or horizontal, but these are all linear equations. And you can see, just looking at them, you can also see that the exponent's highest power is 1. All right, so let's talk about slope-intercept form. Slope-intercept form of a line is when it's written like this, and you have y equals mx plus b. The m stands for the slope, and the b is the y-intercept. And I'm not spending a lot of time talking about these because I'm assuming you probably already know this. So what is the slope? Well, the slope tells you the steepness of the line. So if we look over here, here's an example of an equation. And if we think of our slope-intercept form of a line, y equals mx plus b, we know that the m, or the leading coefficient for the x, is the slope, and the b is the y-intercept. So here our slope is 2. So that means up 2 over 1. And all of these over here are different ways of writing or thinking about the slope. It's the rise over the run, how many up or down, and over how many over, delta y over delta x, or change in y over change in x, or difference in the y's over difference in the x's. Okay, let's take a look down here. Let's try to graph this. We have the y-intercept of 3, so that means we're going to look at our y-axis and start at 3, and our slope is 2, so that means up 2 over 1. All right, so let's see how I do it. Ugh, so bad. Not very good at drawing the lines on here. All right, well, what about the y-intercept? So the y-intercept tells you where the graph hits or crosses the y-axis. So again, we have this equation here. The y-intercept is 3, so that means if we are looking at our y-axis, this equation is going to hit the y-axis at 3, and the slope is 2, so up 2 over 1. Hey, that one was better. All right, so what if two lines have the same slope and y-intercept? All right, so what if we have something like this, y equals 2x plus 3 and y equals 2x plus 3? Well, if you were graphing these, I'm sure you could tell that you're going to be graphing the exact same line right on top of itself. So 2x plus 3. All right, so this is going to look like this. And if I chose a different color to try to do the other one, I am going to be copying exactly what I just did and going right on top of it. So if two lines have the same slope and the same y-intercept, that means they are the exact same line. What if two lines have the same slopes and different y-intercepts? So same slopes and different y-intercepts. So something like that might be 3x plus 2 and y equals 3x minus 4. The slopes are the same. The y-intercepts are different. So let's take a look at this. So this is 2, and then up 3, 1, 2, 3, 1, 2, 3. Sounds like a dance. All right. so this is the first one. Now let's do the other one. All right, 3x plus 4. Oh, minus 4. 1, 2, 1, 2, 3, 4. And then up 3 over 1, up 3 over 1. Okay. All right, so what does that look like there? So if you have two lines that have the same slopes but different y-intercepts, that means that the lines are parallel. They are never going to touch. So they both start at different points on the y-axis, but they are moving up and over the same amount each time. So they're never going to touch each other. So if two lines have the same slopes and different y-intercepts, they are parallel. If they have the same slope and y-intercept, they are the same line. All right, what about if they have different slopes? All right, so let's take a look at what that would look like. So what about y equals 3x plus 2 and y equals negative 1/2 x minus 5? All right, so let's start with this one. Y equals 3x plus 2. So we're going to start at 2 and then go up 3 over 1. Okay, so the graph looks something like this. All right, and now let's do the other one. So we have negative 1/2 x minus 5. So 1, 2, 3, 4, 5. And then down 1 over 2, down 1 over 2. All right. And yeah, I'll extend that one. All right, so what's going to happen if we have different slopes? The lines will intersect. So if the two lines have different slopes, they will cross at some point. So the three situations are same slope, same y-intercept, same line. They're going to overlap exactly. Same slope, different intercepts, they are parallel. Different slopes, they are two different lines and they're going to cross at one point. All right, so now that we have that covered, let's get to the topic that we were supposed to be covering. So you might be thinking, wait, I'm already able to solve equations. All right, so let's try this. So let's solve this. 5x take away 2x is 3x. And then we have minus 7. And on this side, we have 3x minus 5. All right, now we want to get the variables all on one side. So that cancels, and it also cancels on this side. So now I have negative 7 equals negative 5. And that is not true. That is false. Okay, so what happened here? This is a situation where we have a linear equation that will have no solutions. So why is this happening? Let's take a look at this one now. So we have 3x plus 3 and 3x plus 4. So we see, if we think of each side of the equation here as its own linear equation, on this side we have 3x plus 3, and on this side we have 3x plus 4. So if we think of graphing this, we could think of this side's going to have a line and this side's going to have a line. And think about what we just talked about, the 3x plus 3 one. So that is going to be some kind of a line like this. And then the 3x plus 4 one is going to be the exact same line, just shifted up 1 unit. Okay? So when are those going to be equal to each other? When are they going to cross? Or when are they going to have the same x values at the same time? Never, because these are parallel lines. They will never intersect. So if you have two lines that have the same slope and different y-intercepts, you know that they're parallel. So if you're trying to set those equal to each other, that's never going to happen because they don't cross. So if you work this out all the way to the end, you're going to get 3 equals 4, and that's a false statement. So if you get a false statement at the end, you have an equation that has no solutions. Or if you get to this point here and you see that you have two different linear equations, same slopes, different constants, or different y-intercepts, you know that you have parallel lines. It's going to be no solution. So the three different situations we may have here are that a linear equation could have one solution, no solutions, or infinite solutions. If it's going to have one solution, that means that you have two different lines. They are not parallel. Okay, so this means also we could also think of it as we have different slopes. An example of this might be like that 3x plus 2 equals 1/3 x minus 5. All right, different slopes so that we know they are going to cross. And that means it's going to have exactly one solution, which is the place where they cross. And that graph doesn't match that. So, but just two different examples of what you're looking at for situations where there's one solution. All right, no solutions. So this is going to happen if you have two parallel lines, and the graph might look something like this. So when are they going to cross? When are they going to have the same x or y? Never. Okay, so and the equation might look like this. 3x plus 3 equals 3x minus 2. So this situation we have same slopes but different y-intercepts. So we know we have parallel lines. In the end, we're going to get 3 equals -2, and that is false. If you get a false in the end, you know that there's no solutions. In the end for this one, we would get x equals and an answer there. So if you get something like that in the end, you know that there is exactly one solution. So infinite solutions. This means we have the exact same line laying right on top of itself. For example, y equals 2x, or, let me rewrite that. We can do (2x) equals 2x. Okay, so they're the exact same thing on both sides, or maybe you have 2x plus 1 equals 2x plus 1. Okay, this is another example where we have the exact same thing on both sides. Or if you look at a graph, we have a line and then the same line right on top of it. So where are the points going to match up, or where do they intersect? The whole line would be the intersection because they're the exact same thing. So all the points match up. So that's why there's infinite solutions. All right, so let's take a look at these. So let's go ahead and solve these down to the end and see what happens. So if we're trying to isolate our variable, we get 3x equals -2x. Now I'll bring that 2x over. So we get 5x equals 0. And then we divide it by 5. And we get x equals 0. All right, so these two lines for these equations would match when x equals 0. So for one solution, you're looking for the intersection of the graphs, and algebraically, you would work it down to the end where you isolate the variable and you get the answer like that. And this is probably the one you mostly think of when you think of solving an equation. All right, next one over here. So let's try to isolate the variable. We'll bring this 7 over. So we have 3x equals 3x plus 1. Then we'll bring that 3x on the other side. And get 0 equals 1. All right, that is a false statement. So that means that this is a situation where there are no solutions. And if you graphed it, you would see like you have parallel lines. They're never going to intersect. And if you look at it just from this point, you'd say, hey, same slopes, different y-intercepts. This is going to be a no solution because they are parallel. All right, for this one, the exact same thing on both sides of that equal sign. So if we graphed it, we would be doing one graph, like that green arrow that had been down there. And then if we graph the other side, picture maybe that pink arrow, they're right on top of each other. They overlap for every single point because they're the exact same. So this is why we would have infinite solutions All right, so let's just try a couple of these. You can pause the lesson and try it. So work this out, clean it up all the way down to the end, and tell me whether or not it's going to have 1, 0, or infinite solutions. So pause the lesson and work it out, and then hit play when you're ready to check your work. All right, so the first thing we want to do when we're doing this is we want to clean up both sides of the equal sign. So first thing you want to do is get rid of any enclosures, and we don't have any on the left. Now let's combine our like terms here. So 7 take away 3 is 4x plus 10. Okay, on this side, let's deal with this first. So we have plus 2x. So we have a 2x and a 2x, so we have 4x again, and then we have a 10. Right? So right here, you could probably already tell it's the same thing on both sides. It's an infinite solution problem. But let's carry it out to the end just to see what we do here. All right, so we have 4x equals 4x. And then if we wanted, we could divide by x or 4, it doesn't matter. We get x equals x. So in the end, if you get something that's the exact same on both sides of the equal sign, you know you have infinite solutions because it's the exact same line on top of itself. All right, so let's try this one here. So first step is clean up both sides. So we have an x, take away 4. We have x plus 1. All right, so we might recognize right here that we have same slopes, different intercepts. So this would be 2 different lines that are parallel. So there would be no solutions. But let's keep going with this and see what we get at the end. So we'll bring this 1 over. So we get x take away 5 equals x. Then when we bring this x over, we get negative 5 equals 0. And that's a false statement. So we know there's no solutions to that one. All right, so let's try making some equations now. So let's make an equation with an infinite number of solutions. So let's think about when is that going to happen? So if we want an infinite number of solutions, that means that we have to have a line on one side and that exact same line on the other side. So we want same slope. Maybe I'll do 1/2 x for the slope. And we want the same y-intercepts. Right? I have the same exact thing on both sides. So that is going to be a situation where we have an infinite number of solutions. We can work it out and see what we get in the end. So if we wanted to take away 1/2 x from both sides, then we're left with 3 equals 3. So no matter what I do, that's going to be true all the time. There's an infinite number of solutions to that. All right, what about no solutions? So we know that we are going to have 2 lines that will never intersect. And when does that happen? When they are parallel. So we want to have the same slope. I'm going to do this one a little different. So we want to have the same slope. Maybe we'll do 4x. And different y-intercepts. Okay, now we have 2 lines that are parallel on both sides of this. And if we just work it all the way to the end here, let's see what we get. So we get 3 equals negative 4. And that is a false statement. And that's what we wanted, was something that would give us no solutions. One solution. So let's think about when is this going to happen. So this is going to happen when we have different slopes. So if we have 2x and 4x, the slopes are different now, and we can put whatever we want for the y-intercepts. Okay, now we have a situation where we should end up in the end with something that's going to have just one solution. So x equals something. So let's try to clean this up and see what we get. We'll bring this 2x over. We get 1 equals 2x take away 5. Now we'll add 5 to both sides. So we get 6 equals 2x. Now we're multiplying by 2. We'll undo that by dividing by 2, and we get 3 equals x. All right, yay. So this type of an answer is the kind you get when you have exactly one solution. All right, so now it's your turn to practice. So pause the lesson, try to work through these. The first 3 up top, you're going to tell how many solutions each equation would have. And then the bottom, you're going to come up with your own equations. And then once you're done, hit play and we will go over the answers. All right, so number 1 up here. First, let's clean up each side. So we have 3x and then take away 2. And we have 3x plus 6. Okay, we can bring that 3x over. So we get negative 2 equals 6. And that is false. So there are going to be 0 solutions for that. And you can also just tell here, same slopes, different y-intercepts. There would be no solutions to that. All right, next one, let's clean this up. We have 5x take away 4 equals 5x plus 4. All right, same situation looks like. So if we clean this up more, we get negative 4 equals 4, and that is false. So there are no solutions to that one. All right, number 3 down here, let's clean up this one. Let me get a color that'll show up here. All right, so first let's deal with that. It's going to be plus 6x. So we have 6x and 2x, so we have 8x. And negative 6 and 4 is negative 2. On the other side, we have 8x and negative 2. All right, same thing on both sides. So that means that these 2 lines are going to lay right on top of each other. They are going to have an infinite number of solutions. But if we work it out to the end, we can see if we take 8x away from both sides, then we end up with 2 equals 2. And if you get something like that at the end, where you have something, the equal sign, and the exact same thing on the other side, there is an infinite number of solutions. And for number 4 down here, write something that has an infinite number of solutions. So we have, I'm just going to set us up with our blank slope-intercept forms. All right. Infinite solutions means the exact same line on both sides. So whatever I do for one side, I have to do the exact same thing for the other side. So there are 2 lines that are exactly the same on both sides of that equal sign. There would be an infinite number of solutions. Yours is, I'm sure yours is different than mine, but as long as you have this exact same thing on both sides of your equal sign, you have it. Here, something that has 0 solutions. So again, I'm going to set up my fill in the blanks for my slope-intercept form. All right, so no solutions, that means my lines have to be parallel. So that means same slope, different y-intercepts. Okay, so that's going to work out to be a no solution. And then one solution, set up my fill in the blanks. For this one solution, that means that my lines cannot be the same line, so they can't be the exact same, and they can't be parallel. So that means they have to have different slopes. So I'll make this one have 2x, and I'll make this one have 1/2 x. Oop, and the x was already there. I didn't need to write that again. So 2x, and then my y-intercept, I could choose whatever I want for those. 2x plus 3 and 1/2 x. We'll switch that just so you can see. It doesn't matter if it's positives or negatives here. 1/2 x minus 8. Okay, so we have 2 different lines here that will cross in exactly one point. This will have one solution. What I'd like to do here is just go over each situation, just summarize what we talked about here. So a linear equation might have one solution, no solutions, or infinite solutions. If it is a one solution situation, that means if we picture it graphically, we have 2 lines that are going to intersect at exactly one point, and that is the solution. If we think of it algebraically, this means that we have two lines that are not the same line and they are not parallel, so they have different slopes. So I'm going to set this up as different slopes. Okay, so they have different slopes here, so we know that they will intersect at exactly one spot. And in the end, if we'll just carry this through here, we bring that 2x over, we get 5 equals x take away 2, 7 equals x. In the end, if you get something where you have x equals something or like another variable, this means that there is exactly one solution. For no solutions, if we picture it graphically, we would be talking about we'd be talking about a pair of parallel lines. And if we think of what that would mean in an equation, that means that we have two lines that have the same slope and they have different y-intercepts. Okay, so these lines will never touch and there will be no point that they are equal to each other. And if we solve this, if we isolate the variable, we end up with 3 equals negative 5, and that is a false statement. So if you get a false statement in the end, there are no solutions. An infinite solution situation will be if we think of a line and placing another line right on top of it. So where would they be equal to each other? For every single point, no matter what it is, because they are the exact same line. So if we think of an equation that might fit this situation, 2x plus 3, 2x plus 3. Same exact thing on both sides. Okay, and if we clean it up to the end, if we try to isolate the variable, well, those will go away and we end up with like 3 equals 3, or we could have gotten rid of the 3's and we could have ended up with x equals x in the end. If you get something as equal to itself, you know that there is an infinite number of solutions. So one solution, if you get y equals something or x equals something. No solutions if you get a false statement, and an infinite number of solutions if you get something is equal to itself. All right, so hopefully that helped you understand when there would be one solution, no solutions, and infinite solutions for a linear equation.